Hello everyone, I'm Xiao Gang. Okay, in this lesson, we'll mainly look at an overview of networking from our official documentation. Some content is quite complex and advanced, which we'll skip over, and we'll tell you that you can ignore this part for now. In online games, information is transmitted across multiple computers through network connections, so it's definitely much more complex than a single-player game. And our Unreal Engine is very powerful, because it handles the underlying network connection encapsulation for you and offers various high-level interfaces. It can help us quickly build a multiplayer game. So first of all, if you want to make a game, you better plan it as a multiplayer game from the start. Why do this? Because Unreal has already done it for you. You just develop it as a multiplayer game directly, and when you finally package it, or when deploying, just select single-player mode. Because if you're halfway through development and you want to convert the single-player game into a multiplayer game, it will be extremely troublesome. Why is it extremely troublesome? Because you have to restructure the entire project. Because you've already completed development, and you'll need to restructure the entire business layer, the entire functional layer. So let's give a simple example. What kind of situation requires restructuring? For example, take this backpack. This backpack, you wrote it into the UMG because you saw this backpack. I just directly attach it to our UMG. And then attach it to our backpack's item list. If you do networking this way, there will be synchronization issue because on our DS server, you don't have this UMG at all. There are no UI elements whatsoever, and you have some effects, or some effects you usually have, or some functions. You even put them in the animation, or put them in a particle system. Then when you go to implement it, this part of the logic on the DS will behave differently on the presentation layer because the DS server will optimize your character on the server. Since the DS server has no rendering functionality, then for animation, you have a montage. You have a Google position, and you also have these particle effects on the dedicated server. They might not even be generated. Then those related functions might no longer exist. And also, for example, you have some collision functionality. Then when collision occurs, you definitely need to validate it on the server. You write it all. You write it all when it's a standalone game. You haven't considered that both the server and client will have collision situations. So at this point, you must plan more early on for this multiplayer game scenario. Moreover, for a multiplayer game, you also need to consider communication. The most common thing is that you need to consider bandwidth and network stability. Your original approach might have been fine because it was local transmission, so fetching and interacting were fine. But once you get into networking, this skill, when it needs to be validated on the server, some positions and synchronizations, it becomes extremely complicated. So from the start, when everyone designs, they design it as a multi-year game. Then the most common issue, which we've repeatedly mentioned to you before, is that there is no controller on the DS server. If on the DS game mode, you call GetPlayerController 0, congratulations, your game will crash directly. Your DS server won't even start, because when the DS server starts, there are no players. But when you debug it, it might start successfully. You debug in our Unreal Editor, because when you debug in the Unreal Editor, it might launch everything together. So in this case, there are many such details. So when we work on it, I'll explain it to you as I go. Okay, now let's take a look at Unreal's network architecture. It has two architectures. One is local multiplayer or online multiplayer. First, let's talk about local multiplayer, which is what we just mentioned. Split-screen games like this, or fighting games, are actually still processed on our machine. We just have two controllers. Maybe this player uses a controller, and this player uses a keyboard. The simplest example is It Takes Two. Because when I play It Takes Two with my friend, we only run it on this one computer. It's not like he uses one computer and I use another computer. So this is a classic local Multiplayer game? This is called a local multiplayer game. We emphasize that what we are learning are online multiplayer games. Online multiplayer games, as we emphasized earlier, involve many servers. Among them, there is a central server of this kind. We call it a server or host server. It will host our game, and the rest of us players act as clients, connecting to our server. Then the server will take all the information and share the connection with all clients and communicate with all clients among each other. So the challenge this brings is that the player speed is different, each computer's configuration is different, and the network can be unstable. There will be a situation of packet loss, and some players might even cheat. So how do we handle this? So now I have placed a skill on my side. So how does the server synchronize this skill to other states? How to replicate it to other states? Or say, now this player of mine quits. I need to inform other players of this information. A player has quit or he sent a message. How does he handle these audio mixing and track merging? So we need to use this Unreal Engine framework to control it. Anyway, always remember one thing. The server is the truly authoritative state on the client side. We only control our own. What the client controls is our pawn. And this fact is actually a remote fact. We use our client, the character we control ourselves, to the character controlled on the server, send relevant information, remote call information, then let the server execute the corresponding operations. Then the server sends the operation status information after execution, synchronized to all other clients. And here we need to distinguish it from pixel streaming. And here we call it state synchronization. The server does not directly render the image and stream it to the user like playing a video. Instead, the server only packages some relevant key information, Sunday coordinate skill information data, and sends it to you as a package. Then the word parsing we run on the client side. The packet that is sent out, use the information in the packet to map and modify this object in our client side world. And our pixel streaming, it directly sends the rendered video to you. So we need to distinguish here. Then you are on the browser through clicks or keyboard and mouse operations. Then the browser converts these keyboard and mouse operations into network information, sends it to the Unreal rendering program. Then after the program processes, it directly renders the audio and video back. So here is a simple distinction from pixel streaming. Then let's take a closer look at this simple comparison. Obviously, the one on the left is a local multiplayer game, and the one on the right is an online multiplayer game. In this case, this is clearly a listen server, because you will notice that here it forcibly enlarges the target. This indicates that it is acting as the host for other clients to connect to, and here there is only one computer. So let's take a look. If when player 1 presses the fire button, directly fire the current weapon, then directly send the corresponding visual effects and sound effects. This is completely fine. So when writing the single player logic here, I wrote it earlier for you. Just spawn a collision object. When this collision object hits player 2, deal damage and play visual effects. Then handle it randomly like this. This is actually a screen with 2 cameras. Then inside the camera, you can adjust some parameters in this camera. And in this kind of multiplayer interactive experiment, how do we interact? For example, player 1 is the local punk. You press buttons on the controller after pressing the button or punk through the underlying Unreal Engine. Enhanced input system. We made a bunch of bindings earlier by binding them to our pure controller or binding them to our character. We first take the hardware layer through the enhanced input system and convert it to our lay and convert it to our punk. Then through this network information, find the punk that exists on the server, because this thing exists on both the server and the client. So specifically, why is there a need for? We will explain in the next section. Then the server receives your client, transmitting this command over the network. Then the server spawns this projectile. After spawning the projectile, then this projectile must be present on all other clients. Then other clients also spawn a projectile. And then this projectile, after this projectile is spawned, the server will execute the transformation of the projectile's 3-dimensional position coordinates. Then this projectiles, some of its collisions are executed on the server after execution is complete. The result of synchronizing the corresponding 3-dimensional coordinates on the synchronized client. Therefore, after the server notifies the generation of the projectile on the server starts moving and begins real-time synchronization of the projectile's coordinates. Each client also receives these coordinates. When this firing pin function, it only fires on the server. After firing, then we trigger the destruction event. Then other clients can perform destruction. Then when we collide, our server will notify all clients that a collision has occurred at this location. Then all clients will generate the corresponding effects. Then because we collided with player 2, if we only modify the UM7 for player 2, then we will only notify player 2. You have been hit. Your screen should flash, but all other clients will receive this collision object. That is, player 3 and player 4 will both receive the destruction information for this collision object, including player 1. Okay, now let's look at the description here. That is to say, in a local game, all these things happen within one world. In multiplayer games, there are actually many game worlds. This can be very simply divided into the authoritative world on the server, then the client world of player 1, and the client world of player 2. Yes, so actually here, it should still be using a dedicated server. Here, if it specifically describes this authoritative world, because in the case of a listen server, our client world and this authoritative world are these two things. It might be a world, then there is client 3, client 4, and each world actually has its own supporting player controller, weapon release, and other such areas. They must fully simulate the events occurring on the server, but what exactly is divided between the server and the client. Our core gameplay logic, things like collision, movement, and damage, these are all handled on the server. Our presentation layer logic, our visual effects, sound effects, and special effects, our UMG updates, so these are all done on the client side. They will have to be written by ourselves. Which information needs to be executed on the client? Which information needs to be executed on the server? And we also need to minimize such synchronized information to reduce our bandwidth pressure. Okay, alright. So with the basic world established, let's take a look at this underlying layer. What enumerations does it have? Some information structures to help you define, to specify this related information. First of all, then we definitely need to distinguish between these types of characters. So single player is the simplest. It is called stay alone. It is this. We will have a stay alone. So this is essentially a single player game. That is to say, it is considered a server because it contains all the server functions, but it does not accept remote client connections, but just treat it as a single player game. You don't need to think about server or client here. It is a standalone game, and this place is called a dedicated server. It is a dedicated server. This is an optimized version of that. So it has no graphics, sound input, or other user-facing function. This is what we often use for MMO. We need to deploy this dedicated server. As for the listen server, it has a local player on the server. This player will participate in the game. He will host the game. Other clients connect to this player's computer. It is generally used for LAN games like this because we can't set up another machine separately. The client is the one that connects to the server as a client. It can connect to a dedicated server. It can also connect to a listen server. The client does not execute server-side logic. So why do we say Unreal Engine is well packaged? Because in a single-player game, on its flag, it acts as both the server and the client. So when you're making a multiplayer game, you create logic that can run perfectly under a single-player offline network. There is absolutely no problem. Then we can use some red. In the previous chapter, we wrote for you that there is some code that we might have on the server. Some code exists on the client side. So let's make a simple distinction. It can be done through, if we use this red zone to wrap it, that is this gradient code, if we write it using the red zone, then this kind of code will be compiled on both the game and the server. And if you use this server 1, it will only be compiled on the server. Okay, because in the last class, we also wrote this for you. And this thing, let's go to the previous chapter. Then let's take a more detailed look. This listen server. As for the listen server, it is actually mainly used for our LAN games. And then on the host, that is our first player, the host player will have a UI. Actually, this can cause a misunderstanding. That is, you might think the server has a UI. This distinction must be made clear. Moreover, the host player has an advantage because you don't have this bandwidth issue, and you, as the host player, can modify the data, right? Secretly change the data. So its advantage is very significant. But it has one problem, that is, it cannot handle high loads. Because think about it. On a personal PC, your computer's specs, how could it possibly support dozens of people, including your home bandwidth? How could it handle dozens of people connecting to your computer like that? Letting your computer process all the player's logic, your computer would be very laggy. So what we mean is, when we set up a LAN game, whoever has the better computer will be the one to act as the host. As for dedicated servers, their cost is very high. This is because they independently compute all player 井口分 T. They require a separate computer, as well as network connections, and some public network access. However, their advantage is that they do not render graphics, nor do they handle player logic, because we really like to write something within the player logic. For example, when I am a player, I perform some tick logic to update the health bar or to make some other changes, because sometimes, to be lazy, we directly execute it in the tick, then it won't execute this player tick logic, so the pressure is much lower, and at the same time, its fairness is also guaranteed, because all players are clients. They are all equal. Then we use MMO, or we use MOBA or something similar. When there is a strong need for competitiveness, we may use dedicated servers, and it is worth noting that the bandwidth pressure is relatively high. When the bandwidth is insufficient during state synchronization, it will prioritize synchronization of high priority player data, and low priority data may not be guaranteed. This could then affect the overall game experience. Then we refer to the process of sending the server state to the client as replication or synchronization. Since the server state is the most authoritative and unique, we must understand this process. So what kind of class can have such a project? Do we generally base our replication and synchronization on actor? And the Python class of actor replicates its state through network connections in Unreal Engine. Actually, when we talk about it a lot, talking about synchronization, we always talk about it based on actor. Can your object also be discussed? That is, can other types of object be discussed? It is also possible. Think about it. If I have a backpack component, then this backpack component, it is a UAC component. Such a component, of course, it can also support this kind of replication, but it must be attached to an actor. So we are based on actor, based on this channel to do this kind of the concept of network replication. Of course, our object, it can also be synchronized through other methods. We won't go into detail about that. What you need to understand now is we must base it on actor and components like actor component to perform replication and synchronization in this derived class manner. So if we want to replicate and synchronize, first we must mark which properties need to be synchronized, right? Which behaviors need to be synchronized. That's what we'll talk about next. Now there is a new concept, and it may also have some other concepts of synchronization systems. So how does our actor replicate and synchronize? First of all, actually regarding replication, let's go back to what we're going to talk about next. It is actually property synchronization and behavior synchronization. After we mark the properties, the server will, based on changes to these properties, continuously send these properties to the client. In remote procedure calls, we call them behavior synchronization, or RPC, because sometimes we have some operations, it must accept instructions from the client and then go execute them on the server. It's essentially the client calling the server to execute. So this is a remote call, and sometimes we need the server to notify all clients to execute. That is also a remote call, right? It's a remote procedure call. Okay, then later on, we will cover this later. This part tells you how to enable this feature. It actually has a replay variable that controls it. We can see we are here. Let's first have a general idea. In this place, you can see there is a mere replex here. Okay, so when you enable this network replication feature, you also need to specify which specific replications it should use. When you enable it, then obviously during its creation and destruction, it will go through this authority. Through the server, it will notify creation and destruction. If you enable this movement, you can see, then obviously its movement will be synchronized. It will automatically send the position and rotation. Then you can synchronize specific properties. No problem either. Then this component of yours may need to be synchronized. May not be synchronized because sometimes you might be on the server. You need to collect damage information from all players. You want this damage information to only be processed on the server. And the players do not need to know this damage because you think in this game. Regarding this damage mechanism and the lottery mechanism, you do not want to make it public. So this component may only exist on the server, and then there might also be some derived teams that you can attach it to. Decanonize on X. Then we also have some remote call methods. We also need to write them into the actor. Then we use events as a method after we write a method. We can make it into this kind of remote call. Let's write this experiment for 8. Here, you can see here, we can change it to these several methods. We will talk about this later. First, have an overall concept, as mentioned earlier. Regarding if you enable network replication, it first pairs up these objects. After pairing them up, it goes back to process them. Then, next, if you have some additional business or functional needs, you enable them based on your functionality. You decide which properties to replicate and which methods to call. However, some things will not be replicated because these things are very large and generally do not change. For example, some materials, some animation blueprints, or some sounds, or some particle systems, it won't copy. If you want these elements, then because of these visual elements, they appear the same in every bucket. You just need to call it because you are outputting it through the same set of code. So these things are all the same. And actually, in this analysis, Unreal also provides some more debugging tools. It can use some performance analysis tools or some bandwidth. You can see how much bandwidth is currently being used. You can even simulate these delays in the editor. And as for Unreal, it is now gradually increasing step by step because it really hopes in the future definitely use the excellent native ones. The entire movement synchronization, this whole set is very bandwidth intensive, especially under high pressure. Many large teams and big companies, they all optimize it. Unreal Engine is also optimizing it, so they provide this replication graph. And these areas replication systems, these are relatively new things. We won't cover them in this lecture. We'll just cover a simple, most commonly used property replication and behavior replication. Okay? Then this places, it's this kind of general purpose one. Property concurrization and IPC mechanism. Then this is the new one. This replication graph and RIS replication system. If you're basically using it commercially, you basically have to use this. But for us, as beginners learning development, we can just use this general purpose one. And there's a sleep mode here. That means sometimes some actors stop synchronizing. And when we have many actors competing for synchronization bandwidth, we need to prioritize based on priority. Definitely the player-controlled ones come first. There might be some bosses in some minions, then you arrange them. Certainly bosses have higher priority than minions. Then there is some relevance, that is, some things, they might be irrelevant. Then you might exclude them from the start. Then the copy chart in the Aries copy system. We will skip that. And this part is a simple soft optimization. First of all, for this network synchronization, the properties you synchronize should definitely be as few as possible. You want to synchronize health, and also synchronize mana, and also synchronize stamina, and also pay for this potential information. You synchronize this information on all clients and on all servers. Then your bandwidth will definitely not work, and you often, every tick, you make a remote call. Then this is unreasonable because some data, it might only change once every minute or two. But you access it every time. Every time you ask if it has changed, then that is unreasonable. Actually, it's the same with how we optimize tick-related things. And we try to use less of these functions like broadcast. And for some other logic, actually, if you can avoid using RPC, then don't use RPC. And there is also some logic where when the player presses a key, the player sometimes goes ding, 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 ding when they press it the first time. Then you give them a 0.5 second judgment window, meaning that they have already pressed it. 站弹弹至抑制百再待 before allowing them to press again, or I have to wait until the result of this press after it returns from the remote server before allowing them to press again, because if they keep pressing, it will cause our network, this message stack, to explode. Then you won't be able to handle it. So on the client side, you need to implement a restriction for protection. Then you need to distinguish between reliable and unreliable, because some things you call frequently. That is to say, maybe. Maybe if a packet is lost, then it doesn't matter, because in the next frame, or in the next 20 seconds, it will come again, so it doesn't really matter. But for some operations, we must ensure they are reliable. We must ensure the server receives this operation. So the reliable, unreliable aspect here is just to emphasize that. Don't just set everything to reliable. But when you start out, I could also do it this way for packet loss, but you can't do that. But when you optimize later, you'll be in for a painful time. For example, the player's 3D position, right? That kind of thing definitely doesn't need to be set as reliable because you're synchronizing it all the time. But if the player suddenly uses a skill, right? Or suddenly wants to top up or make a payment, then you need to set it as reliable. Because you don't want the player to click once and have it cause issues during the payment process. He didn't top up, this deduction didn't go through. Then your boss would be very angry. Right. Then these are some properties when syncing over the required protections. Then when you differentiate, you still need to separate the server and client logic. Don't let the server do a lot of work, only to find that this part is client logic and it doesn't execute in the end. You should separate server and client logic from the start. It shouldn't even enter from the beginning, right? Then here we can determine our this current punk, whether it is something locally controlled by our player. And network dormancy is also a common optimization method. Okay, so actually at the beginning of this document, we have gone through everything for everyone. So everyone has a concept in mind first, then we will continue with in-depth explanations later.